I'm now joined by two of the key members of the Ceres science team, Dr. Norman Loeb and Dr. Kory Priestley. And Norm and Kory, would you please introduce yourselves to the school audience?
Hi, I'm Norman Loeb. I'm the co-principal investigator on Ceres. Ceres stands for the Clouds in the Earth's Radiant Energy System. And Ceres is essentially what you guys out there taking cloud observations are supporting.
I'm Kory Priestley. I am a member of the Ceres science team and chair of the science team's instrument working group. And as such, I'm responsible for maintaining the instruments on orbit and operating them and making sure they collect all the data that the science team wants us to get.
Okay, Norm, could you start by telling us a little bit about Ceres and about what we've learned in the last 12 years of data?
Okay, I'm not sure if this slide is showing up yet.
There it is.
Okay, this is the global energy budget. It's a very important figure because Ceres tries to measure as much of the components in this figure as possible. So you recognize here there's the sun's energy, which is what we call visible radiation or solar radiation, is essentially what drives our climate. How much of that radiation reaches the surface depends on the kinds of things that you guys are observing, which are the clouds. So roughly half of the sun's energy reaches the surface, and about a third is reflected back to space by clouds. So that is essentially the solar part. And then on the right is the infrared part. So this is infrared radiation. It's radiation that you can't actually see, but any body that has a temperature emits radiation, including the Earth. And so the balance of energy between what comes in and what goes out is really critical to climate and determines the temperature of the Earth. And so the really important things are the clouds, the aerosols, and the surface. And so Ceres measures the radiation that's reflected from the planet and the radiation that's emitted from the planet. And then there's another instrument called MODIS that you'll hear more about later that actually measures the clouds. And having the radiation measurements from Ceres and the cloud measurements from MODIS really enables us to get a very complete picture of the climate system. And so here's kind of a nice animation of the Aqua spacecraft, and these are measurements from Ceres. On Aqua, there are two Ceres measurements, or Ceres instruments, one that is essentially scanning there perpendicular to the motion, and you can see that. And then the other one is rotating in azimuth as it scans in elevation. So you see two beams there collecting data, and the various colors that you see on the Earth there are how much energy is being emitted in the infrared region. So things that are very cold will tend to be bluer or white, and then the warmer colors represent the red. And so you could see at the equatorial regions you tend to see more red, and as you go over the poles it tends to be more white and blue. And so it takes about, the spacecraft is at about 705 kilometers, which is roughly 400 miles. It takes about 90 minutes to complete one orbit of measurements. And we get global coverage every day. And that kind of information is really critical to have on a daily basis at the global level. The next slide is essentially the whole Earth view of the emitted radiation on the left and the reflected solar radiation on the right. And this is supposed to move. So there's March, April, May. And what you see is a lot of changes going on in the system from one month to the other. A lot of this is associated with weather patterns of different clouds. So what we look at there is how are all of these different changes relating to the clouds and the surface. And we're trying to understand physically what goes on in the system. And if we have a lot of these measurements over many, many years, we could then start to see how climate is changing. And so that's one of the critical things that we want to be able to do with the Ceres project. And in order to do that well, we have to make sure that our observations of both the radiation and the clouds are accurate, and that's where you guys come in, because you give us a